Welcome to the Bodhi Academy. My name is Amsha Klasso, and in today's video we will continue with our chapter Solutions, Class 12, Chapter 1. So in today's video we will learn about a specific set of solutions known as the ideal and non-ideal solutions. Now the liquid solutions, which are there in which the solvent is the liquid and the solute is also in the liquid state. In that case, these type of solutions can be classified into two categories, that is ideal and non-ideal, based on the preference they show towards the Raoult's law. Now the solutions which obey the Raoult's law over the entire range of concentration are known as ideal solutions. Okay, the solutions which basically obey the Raoult's law, which tells us that the mole fraction is directly proportional to its vapor pressure, correct? So in that case we can say the ones which obey this rule over any concentration, it can be any concentration ranging from 0.1 to anything. In that case, this range of concentration, all of it, if it follows, then we can say then these are called as the ideal solutions. Now these ideal solutions have two more properties to understand. The first one is that the solutions which obey the Raoult's law over the entire range of concentration are known as ideal solutions. The enthalpy of mixing of pure components to form the solution is 0. So the enthalpy of mixing of pure components to form the solution is 0. That is the first property, and the second is the volume of mixing is also 0. In short, what these two properties are telling us is that first is that no heat is evolved or absorbed when the components are mixed. On mixing these two liquids, there is no absorption or evolution of any kind of heat that is happening. So delta that is enthalpy delta H of the mixture comes to be 0, and also that the volume of the solution, it is the sum of both the components that are present in the solution, that is component A plus component B. Now if at molecular level, if we speak about ideal behavior of solutions, it can be explained by considering say two components A and B. Now for pure components, what we can see is that the intermolecular attractive interactions are going to be either AA, or we can say solute interactions, or BB, that is solvent interactions. Now but in case of binary solutions, when we have a mixture of two components, in that case we will have AB kind of interactions where we will have a solute to solvent interactions. Now if the interactive attractive forces between AA and BB are nearly equal to those between AB, this leads to the formation of ideal solution. Now when we say about pure components, if this interaction which is happening between AA and BB, if these two interactions are equal to that of these AB interactions, only in that case we can say that this leads to the formation of ideal solutions. Okay. Now ideal solutions are rarely present, but some of the solutions which are nearly to ideal behavior are these ones, that is solution of N-hexane and N-heptane, bromoethane and chloroethane, benzene and toluene, etc. They all fall into this category. Okay. Now what about the non-ideal solutions? So the solutions which do not obey the Raoult's law over the entire range of concentration, they are called as non-ideal solution, wherein they are saying that the mole fraction is not directly proportional to that of the vapor pressure of the solution. Now the vapor pressure of such a solution is either high or low than that predicted by the Raoult's law. In that case, what we are saying is that the vapor pressure is going to be high or low than what is predicted by Raoult's law. In that case, the vapor pressure was equal to what is being predicted by Raoult's law. Here it is going to have a variation of either it is going to be higher or lower than the Raoult's law prediction. Now if the vapor, if it is higher, if the vapor pressure is higher than that of the predicted Raoult's law, then the solution is said to exhibit a positive deviation. Okay, and if it is lower, then the solution is said to exhibit a negative deviation. Now let's understand what is this positive and negative deviation. In positive deviation, what we see is that this AB interactions are solute with solvent interactions are weaker than the AA and BB interactions. So what we are saying is that the solute and solvent interactions, they are weaker than the solute to solute and solvent to solvent interactions. So solute to solute and solvent to solvent, that is pure component interactions, are much higher than the binary solutions, that is A to B. Now and also here what will happen is that because of this the vapor pressure will increase. Now example of this is mixtures of ethanol and acetone behave in this manner. Okay, and another is that in a solution that is formed by adding carbon disulfide to acetone, it also behaves in a similar way. Now the negative deviation is going to be the opposite of the positive deviation. So in this case what will be weaker? The AA or the BB interactions, that is the solute or solvent interactions, are going to be weaker than the solute solvent interactions, and therefore this will cause a decrease in the vapor pressure. Therefore we are getting a negative deviation, because what we said that if the value of vapor pressure of the solution is lower, then we can say that it is a negative deviation. Example of this would be a mixture of phenol and aniline and a mixture of chloroform and acetone, that forms a solution with a negative deviation. Now some liquids which are there, some exceptional liquids, on mixing they form this azeotropes. Okay, now this azeotropes, which are binary mixtures, have a same composition in liquid and vapor phase and boil at a constant temperature. So their composition, what they are saying, it is same even at liquid and at a vapor phase it is equal, and also that they boil at a constant temperature. Now we have two types of, again we have this azeotropes that are divided in two categories. One is the maximum boiling azeotrope and the second is the minimum boiling azeotrope. Now the maximum boiling azeotrope, it shows a large negative deviation from the Raoult's law at specific composition. Okay, so the maximum boiling azeotropes are the one which show a large negative deviation. Negative deviation, when we say it, we know that which interactions are weaker, that the A to A or B to B interactions are weaker and A to B interactions are stronger in that case. Example of this is nitric acid and water. And the minimum boiling azeotropes are the ones which show a large positive deviation from the Raoult's law at specific composition. Example of this is ethanol water mixture, that is obtained by fermentation of sugars. Now large positive deviation, when we say, we know which interactions are weaker, that is the A-B interactions, that is the binary solution interactions are weaker in this case. Okay, so that was it about ideal and non-ideal solutions. I hope you have understood. Please don't forget to like, share and subscribe to the Bodhi Academy.